Hey, third grade, this is your math video for math lesson 7.9. For this math lesson, you are going to need your whiteboards and your workbooks. We're going to start on our whiteboards, go to our workbooks, and then finish on our whiteboards. But we're going to be looking at a couple different things today with fractions. The first one is partitioning distances to locate fractions on number lines. What that means is just breaking up a number line. So if I just give you a blank one that says 0 to 1, and I tell you to split it into thirds, do you understand how to find that on a number line? The other part we're going to be looking at is the benchmark fraction 1/2. So what 1/2 looks like on different number lines, because that's a really important benchmark that you can use when you're trying to understand fractions and locate them on a number line. So to start, we're going to be on our whiteboards doing quick look cards with different fractions. So on your whiteboards, please write down what fraction you see on this quick look card. All right, so this one would be 3/4. Did you have 3/4 on your whiteboard? So remember, 3 is the numerator. That's telling you how many pieces are shaded in. 4 is the denominator. It's telling you how many pieces there are total. Let's try another one. Go ahead. This would be 1/3. Remember, there's 1 piece filled in and 3 total pieces or parts. And our last quick look card, go ahead and write this one on your whiteboard. So check out how many pieces are shaded in and then how many total pieces. This one would be 1/6 because there is 1 piece filled in and then there are 6 pieces total. Now, if you look at our 3, you can kind of see them over here. Are any of these equivalent, meaning equal? Nope, they're not because they have different amounts shaded in. All right, so now we're going to move to our workbooks, but don't go far with your whiteboards because we're going to finish on those. So let me move my picture up here. All right, so we are going to be on our workbooks on page 240. So your math journal, page 240. So you can pause the video while you grab your math journal and turn to page 240. So at the top of your workbook page, it says locating 1/2 on number lines, and it has the math message. So it says the whole is the distance from 0 to 1. Label 1/2 where you think it should go on the number line. Share your thinking with your partner. Well, I will be your partner for today. So you want to look at it, and if you look, it says 0 to 1. The whole is 0 to 1. Now, on your workbook in pencil, I want you to mark where you think 1/2 would be from 0 to 1. Okay, you're only focusing on that one whole part of the number line. Okay. So now what we're going to look at is where 1/2 would go. So compare where I'm putting mine to where you put yours. Now, obviously my numbers are a lot bigger, but I would put my partition right about here, but halfway between 0 and 1. Now, whenever I was doing this prompt with you, and I said about putting it between 0 and 1, that's because this number line is showing 2 wholes. It's not just showing 1, it has 2 whole fractions on it. 0 to 1 is 1, 1 to 2 is also 1. So in this case, it just wanted you to separate or find the 1/2 benchmark between 0 and 1, which would be right about here. Again, it's not perfect, but as long as you can tell it's about halfway, then that's what you want to do for your workbook, okay? So then you can place the other fractions on the number line. So I have the other 4 down here, so 0/2, 2/2, 3/2, or 4/2. Okay, so using those, I want you to put those on your number line from 0 to 2, where you think those other fractions would go. So you can pause the video while you do that, and then you can start it when you're ready for the answers. So in this case, our first one, which is 0/2, would go at 0. We know that we've practiced that because at that point you have no parts of your fraction, so it would be 0/2. Then we have our halfway mark. And then what would we put for the 1 whole fraction? we would put 2 halves or 2 over 2 because that's one of the ways that we can represent this number. Then we have to do our second halfway mark between 1 and 2. So this one would be 3 halves, and then our last one would be 4 halves. So when we look at our number line, 4 halves or 4 over 2 is equivalent or equal to 2 wholes, 2 whole fractions. But look here, the halfway point between 1 and 2 is listed as 3 halves because our number line is showing 1 and then 2 whole fractions. But if this was just between 1 and 2, this 3 halves could be 1 half. Like this is still halfway between 1 and 2. The reason it's 3 halves is because we're looking at the whole number line. We're looking from 0 all the way up to 2. So this is when we start getting into fractions that are greater than 1. But just know it is still halfway, okay? There's still a half here. It's just represented a little bit differently. So that's what we're going to kind of get into next. So the next part of your book is listed as questions 1 and 2 under your math message. So before we get into that, we are going to look at a quick screenshot from a video talking about different ways to represent fractions. All right, so the next part we're going to look at will help us with the second part of this workbook page. So what this is saying is it says when each whole is divided into one part, the 1 is the denominator, okay? So how that looks would be for the numerator and the denominator, 1 over 1 would equal 1 whole, okay? Because what that would mean is as we're going through fractions and we're dividing them up into pieces like pizzas or pies, we're breaking them into parts. But if you would just leave it 1 whole pizza, you wouldn't cut it at all. Or 1 whole pie, you wouldn't cut it at all. There's only 1 part. So for that, it would mean that 1 over 1 would be equal to 1. Or if I have 2 over 1, that would be like having 2 whole pizzas. So that's where the 2 comes in because there's 2 pizzas. And then the 1 is telling you how many pieces there are. There's only 1 piece. There's only 1 piece to the pizza. It's the whole pizza. So in that case, you would have 2 whole pizzas. Then if I go to 3 pieces or 3 total, that would be like having 3 full pizzas, no slices, just 3 round pizzas, and only 1 part for each pizza. Same with 4 over 1 and same with 5 over 1. So saying the numerator over the denominator, saying the number of totals over the number of pieces being 1, that would also give us 1 whole number. So 1 over 1 would equal 1. 2 over 1 equals 2. 3 over 1 equals 3. 4 over 1 equals 4. And 5 over 1 equals 5. So when I had 5 over 1, that would be like giving you 5 full pizzas that are not cut into any part. There's just 1 circle, 1 part to it, okay? The reason that works is because fractions can also relate to division. So when you divide it, so 2 divided by 1 would equal 2. Any number divided by 1 equals itself. So 3 divided by 1 equals 3. 4 divided by 1 equals 4, okay? So that's just something to keep in the back of your mind as we go into the next examples. So this is still on page 240 in your workbook. So what I want you to do is I want you to look at problem number 1. So if the distance from 0 to 1 is the whole, okay, that's the whole, how many wholes are on this number line? Okay, so from 0 to 1 is the whole. How many wholes would be on this number line? There would be 3 because we have 1, 2, 3. Now, what do you notice about the length of the holes on this number line compared to our math message? So look up at your math message. Yours is closer, but what do you notice about the holes for this one compared to the math message? So they actually are shorter. So in this one, they're longer than they are in this one. But why do you think that's the reason? Look at how many holes are on this number line, and then how many holes are on your math message. So in this case, the reason that they are shorter on this one is because we actually have 3 holes on our number line and not 2. So that makes our spaces smaller because we're trying to fit them in on that number line. So what I want you to do on that first number line is I want you to locate 1/2 on that first number line. Okay, locate 1/2. So here's 0 to 1, and where would we put 1/2 on that number line? Okay, so if you need help, I will show you where I would put 1/2. So here is where 1/2 would be. So from 0 to 1, that's our hole, and then we would mark the halfway point. So now I want you to look at number 2, and I want you to again look at how many holes are on this number line. So number line 1 had 3. How many are on number line 2? There would be 6 because look, this is 1, 2, 3, 4, 5, 6. So up until this point, we've really been looking at just like from 0 to 1 or 0 to 2, but this is what it would look like to represent 6 holes on a number line. So now the next part is we want to label 1/2 on our second number line. So it's 0 to 1, and we would mark it as 1/2. So remember, we talked about at the beginning of the video, always checking to see where our halfway benchmark is. And this is where it would be for both of these fractions. So now we have located the distance from 0 to 1, as well as 0 to 1/2 or 1/2. And with both of these number lines, the distance from 0 to 1/2 of the whole appear to get shorter. So if you look at this one, it was here, and then we moved it back a little, and then we moved it back even more. The reason it's doing that is because the distance from 0 to 1 is getting shorter the more that we put on the number line. So that's kind of showing you just how you can find 1/2, but it also helps you recognize what your number line is looking like and what the rest of the fractions will look like. So now the next part is relating to what we talked about on the last slide, how to represent whole numbers as fractions. So in this case, we have 0 to 1. What is another way that we could represent 1 as a whole number? It would be 1/1. Now, the thing that can look confusing about this is because you have 1/2. You guys are so used to looking at that denominator and then saying this would be 2/2. But we just marked the 1/2 just to recognize where the halfway point is and how it's getting shorter the more holes you put on the number line. The way we're marking our number line now is not in relation to that 1/2. It's more talking about the whole numbers. So for this one, 0 to 1 would be 1/1. 0 to 2, so now we don't have 1 circle, we would have 2 circles. So this would now be 2/1. Because remember, we can represent one whole as 1/1, which is equivalent to 1 whole. Now, if we keep going, continue to trace the distance from 0 to 2, that's what we did. 2 holes is also 2/1. Then we keep going to 3/1. Oops, grabbed the wrong one. There we go. 3 holes, 4 holes, 5 holes, and then 6 holes. I kind of jumped that one up. So I want you to write this down on your number line for this problem, as well as writing the halfway mark or the 1/2. Okay, so what I want you to recognize with these two number lines is that they're showing different numbers of holes. So the first one is 3 holes, the second one is 6 holes. They're showing you them by showing more or fewer whole numbers, but not changing the distance from 0 to 1. So no matter what the size of the distance, it always represents a hole on a number line. And 1/2 is always located halfway between 0 and 1 and represents half of that whole. That's where the key is, okay? So what it's pointing out is that by showing you more whole numbers, it's getting shorter and shorter, but that halfway distance never changes. It's always halfway between 0 and the whole number, okay? So with the fractions, what you're going to be doing is you're going to be practicing partitioning them, meaning dividing them up. So for these, most of the tally marks were already there. But one of the parts of fractions is you are going to have to start looking at a blank number line and start adding in the different tally marks where your fractions are located.